Hello, and welcome to the Robotech training session on our automatic motor sensor and tuning setup wizard for our Robo G4 motor drives. I'm happy to be your guide as we delve into the intricacies of optimizing motor performance in an industrial setting. During this training, we will utilize a pair of brushless DC NEDEC motors and a Robo G4 drive, which we will configure and tune using the automated wizard. The automated process saves development time and ensures that optimal motor performance is achieved, thus improving application productivity and accuracy. The motor we will be using is equipped with a pair of Hall and encoder sensors, which we will set up and calibrate using the automated wizard. While we will be using these specific sensors, the wizard is compatible with all types of sensors, supported by Robotech drives. To begin, we will first ensure our hardware is correctly connected. We must ensure our motor cables are connected according to the motor and controller datasheet. The Hall sensors and encoders are connected to the corresponding Molex connector and DB25 port respectively. The controller should be connected to a power source and powered on, and the controller should be connected via the mini USB port to your PC. Once the prior steps are followed, we can then launch the RoboRun Plus version 3.0 PC software in which we can connect to the controller. We're now presented with a pop-up window asking if we would like to read the controller configuration. Click No, as there is no prior drive configuration needed at this step, since the wizard will assist in the configuration of the system. From here, we can then select the Motor Sensor and Tuning Setup button from the Configuration tab of RoboRun Plus. Once inside the tuning wizard, we are welcomed on the first page with an overview of what the wizard will accomplish. We could go ahead and then click Next. We are prompted to ensure that the motor is free to move and that all load is disconnected, along with some warnings about motor movement and sensor connections. At this point, our AGV is lifted with no load on the motors, allowing them to freely rotate. We can then click Next. In the next page, we are presented with the motor configuration screen. For this, we will need to reference our motor data sheet to obtain the essential parameters. The first parameter is the number of pole pairs. If the datasheet lists the number of poles instead of the pole pairs, you simply divide the number by 2. In our case, our datasheet lists 10 poles, and thus we divide it by 2 to get 5 pole pairs. Next is the amps limit, which is the maximum current that the drive is allowed to provide to the motor. This should be set as the maximum current of the motor. Then we adjust the reference seek power, which is the current that will be consumed during the calibration of the motor's sensor and must be set to the motor's nominal current. Our motor is rated for 21.6 amps. The motor direction will need to be set depending on the application. Since we are using our dual channel motor controller in an AGV application, we will set channel 1 as inverted. Please note that in electric vehicle applications using differential drive, setting one motor direction as direct and the other as inverted will result in the vehicle moving straight when a positive motor command is issued for both motors. The actual direction of each motor may vary depending on the motor phase sequence, therefore always test with care. The Molex input is used as Hall sensors. Since our motor's incorporated Hall sensor will be connected here, next, we set up our sinusoidal angle sensor to Hall plus encoder. Using this combination of both sensors allows for the most precise commutation and ensures the most accurate results. Lastly, set the encoder's resolution. This is the number of the sensor's pulses per revolution. Our motor has 4,096 pulses per revolution. We can then click Next. The system will recognize we are utilizing trapezoidal switching mode and will recommend we switch to sinusoidal commutation, which provides quieter motor performance with less torque ripple. So we click Yes. We will then be presented with the motor sensor setup procedure, which will align the sensor with the motor phases. Click the Run Setup Procedure button. The motor will move slightly during this step. Let this finish. Note that in dual channel controllers, the motor sensor setup will not be established if both motor sensors are not connected in both channels. In case a configuration wizard is used to configure only one channel, the sensor error detection on the unused channel should be disabled. We can then click Next. We're now prompted to perform the same task for channel 2, which we will accept and perform.